Hello everyone, welcome back to Edumoon tutorials. In today's lecture, we will be covering Boolean functions. Myself Sohana of Andhra University, and let's get started. Now, a Boolean function described by an algebraic expression consists of binary variables. Now here what are binary variables? It can be x, y, z, a or b, any kind of alphabets. And the constants 0 and 1 and the logic operation symbols. The logic operation symbols refers to AND, or, not, XOR, XNOR or etc. Now for a given value of the binary variables, the function can be equal to either 0 or 1. Now consider f1 equals to x plus y bar z. Now this entire one is called as a Boolean function. Here x, y and z are called as binary variables. Now each x, y and z can take either the values 0 or 1. Now depending on these values, so like 0 or 1 for these variables, f1's function's value will be determined. Now for example, let us consider x to be 1 and y bar equals to a 0, then z equals to 0. If y bar equals to 0, then y equals to 1. So you can just comprehend from that one. Now 1 plus 0.0 equals to 1. So your f1 value will be 1 for these kind of values. Now a Boolean function can be represented in a truth table. Now how many rows are required for that given truth table? It is 2 power n, where n equals to number of variables in the given function. So if you consider this function, we have 3 binary variables like x, y and z. So the number of rows that are required are 2 cube, which is equals to 8. So the truth table for this one can be written as like this one, like x, y and z, so f1. So these 3 will be having the values ranging from 0 till 7, 0, 0, 0, 0, 0, 1. I hope you know from all these values right from the basics. Now, how can your f1 value be determined? As we have the function f1 equals to x plus y bar z, from this we need to find the values. So if x is 0 and y is 0 and z is 0, your value is 0. If x is 0 and y is 0 means it is a 1 and then again a 1. So 1.1 equals to 1 plus a 0, which is equals to 0. In a similar way, you can write all these values. I'll just mention them because I have already done that. You can pause the video and cross check your values. The most prominent kind of questions that are asked for Boolean functions are, you need to draw a logical diagram, or you will be given a logical diagram entirely and then asked to find the Boolean expression for that. We will consider these type of problems in this particular video. Now, how do we draw a logical diagram for the given Boolean function? Now here we have x, y and z, right? So what we will be doing is x, y and z. Always make 2 kind of inputs for x, y and z, because the only 2 inputs for any Boolean variable is 0 or 1. So this is a normal input and this is a not input. Initially you are supposed to draw all the kind of gates like this. This is if this is 0, then this will be a 1. Similarly all these. Now we are asked y bar dot a z. Now just consider these here like y bar dot z. This will be your y bar, which is the not input, and this is your z. So z in your y bar will be having a AND gate, right? AND gate is denoted like this. And your x gate is like this. Now in between both of them there is a plus symbol which stands for OR. Now you need to draw an OR gate. I might have drawn it a little bigger, so just don't mind. This is what the concept behind this. So this one will be your f1. So this input and this input and this input. So this is an x. This is y bar dot z, because this is a AND gate. So y bar dot z. So your f1 here will be x plus, because this is an OR gate, y bar z. Similarly, let's try solving the other question. So given f equals to x bar y plus x y bar. Initially, you need to make 2 inputs for each and every Boolean variable. Okay. Now, x bar dot y. This is your x bar input and this is your y input. As there's an AND gate in between them, you need to place an AND gate here. Next, x dot y bar. This is the input of x and this is the input of y bar. So again an AND gate in between them. Now as there's a plus symbol in between these two terms, we need to draw a OR gate. So this will be your F. I'm just marking a cross symbol here to show that this is the input. So this is an x bar and this is a y dot y and this is an x and this is a dot y bar. So here when you add both of them, f equals to x bar y plus xy bar. I hope you are very clear on how to draw the logical diagrams. Now let's see another kind of questions like what Boolean expression is implemented by the following logic diagram. You might be wondering what is all this stuff and everything, but it is very easy for you to obtain the final Boolean expression. Just carefully observe the kind of gates we are using and where we are using. Now this is an input, this is an input, this is an input and this is an input, right? Now this is an x input and this is a y bar input. Now what gate is placed in between them? It's an AND gate. So x dot y bar. I hope you guys are very clear with this. Now but in this one also, like this is an input of x bar and this is the input of y, x bar dot y. Now this kind of representation is for XNOR. Don't confuse between XOR and XNOR. For XOR you won't be having this bubble. In case of XNOR you will be having this bubble. Now generally if there are two inputs for A as AB, the XNOR will be of the form AB plus A bar B bar. Okay, in case of XOR it is AB bar plus A bar B. Remember these notations carefully. This is an XNOR condition. So in order to find F here, we have x dot y bar and x bar dot y as like inputs like A and B. So what you will be doing? AB plus A bar B bar. So x dot y bar dot x or dot y plus you need to be complementing both of them, which is equals to x bar plus y dot x plus y bar. I'm not solving this. Try to solve this expression and obtain it to the minimum number of literals. I hope you are very clear with the concept of converting the entire bigger Boolean expression into a minimum number of literals. So do find this and let me know in the comment section. Now as a part of homework, I want you guys to find the Boolean expression for this kind of problems. So just pause the video, note down this entire sketch and then find the value of y, like find the Boolean expression for this given logical diagram. The other kind of problems that are being asked under this section are find the complements for the Boolean expressions. Now it is very easy to find the complements. Let us consider a few examples now. Now we are asked to find f bar. How can we find the f bar, which is f complement? So a bar b c bar plus a bar b bar c whole bar. Now according to the De Morgan's law, we have we need to find the complement for this one and for this one. So how do we do that? A bar b c bar whole complement. The complement for plus is a dot and then a bar b bar c whole complement. How do we find the complement for this one? It is a, as a dot is placed in between, we make it to a plus and b is turned to b bar. Now again a dot is converted to plus and c bar is converted to c. Dot. Similarly, a bar is converted to a and dot is converted to plus, b bar is converted to b, a dot is converted to a plus and then it's a c bar. Now try multiplying and expanding the terms, which is aa plus ab plus ac bar plus ab bar plus bb bar plus b bar c bar plus ac plus bc plus cc bar. Now as you can see that bb bar is a 0, cc bar is a 0, right? Now from these terms, wait, I'll just use sketches again. From ab and ab bar, take these terms to be common and then ac bar and then AC. Take these two terms to be common. So we are finally left with values like AA is also an A plus AB and A into B bar. You can write as A into B plus B bar. Right, now again AC and AC bar A into C plus C bar. Plus here a BC term is left and the remaining term is B bar C bar. Now, as you are very aware of the fact that B plus B bar or C plus C bar equals to a 1, then what are we left with? A plus A. Now, if this value is 1 and this value is 1, what kind of values are left here? A plus A plus A. If there are 3 kinds of A or any number of A's like A plus A plus A plus, all of them results to a single Boolean variable which is A itself. So, A plus BC plus B bar C bar is your final answer. I hope you guys are very clear with this concept. All these rules are already discussed in the previous videos. So if you have any doubts, refer to those previous ones and it will be very clear for you. Now let's try solving the other one. Now let this be F. Now we are asked to find the F complement, right? How do we do that? So F bar equals to xy bar z plus x bar yz. I'm just writing the entire question again, don't confuse. xyz whole bar. Now, how do we solve that? Initially, in these two terms itself, there's a yz and yz, right? How can we just write them xy bar z plus yz into x plus x bar? See, I'm not completely going with the complement. I'm just modifying the inner statements itself. So, this is equal to xy bar z plus yz. Now, it's a complement. So, it's clear, right? X plus x bar equals to 1. So I just mentioned it here. Now we need to find the complements for this one. So y dot z whole bar equals to y bar plus z bar dot. Now x y bar z. How to do the complement for that one? It's an x bar plus y plus z bar. Right. Now expand all these terms. It's an x bar y bar plus y bar plus y bar z bar plus x bar z bar plus yz bar plus z bar z bar. Now in case it's a y bar, this is a 0. Now from these two terms like y bar z bar and yz bar, you can take z bar to be common, right? Z bar into y plus y bar. This is equivalent to a z bar. As I'm running out of space, I'm just making it clear here. So what are the terms that are left now? X bar y bar plus a z bar from this one plus z bar equals to a z bar itself again plus x bar and z bar. Now if you consider these two terms like z bar and x bar z bar, you can take z bar to be common and 1 into x 1 plus x bar, which is equals to a 1 again. So it is written like x bar y bar plus z bar plus z bar, which is again z bar plus z bar. It is also equivalent to single z bar. So your final answer will be z bar plus x bar y bar. Don't confuse with all this writing part and everything. Just clearly go with the concepts and then you will be getting the answer as this one. I hope you are very clear with this video. In the next video, we will be covering canonical and standard forms. Till then, stay tuned to Edumoon. Thank you.